This video will cover 8.4 group exercise for Road 1, Chapter 8, Cut and Fill. We're going to create cut and fill volumes for Route 54 in this exercise. Yeah. It showed how to create a mesh surface for the cut and fill volumes and calculate end area volume reports. We'll also learn how to create cross-section models and label them with the end area volume quantities. The process of calculating for a single corridor or multiple corridors requires its own design file, or the tool will calculate all corridors in the design file. So what that's saying is that right now the way this tool works is whichever corridor that you want to do your earthwork calculations on, only that corridor can be in this file. Now if you had multiple corridors that you did want to run the earthwork on, then you would have those corridors in one file together. And you'll see this as we go through the exercise. The first step we want to do is the final feature definition stage, which was design stage before. Now it's the final feature definition. So what we'll do is open up the corridors Route 54 and verify the feature definition is set to 1 final. This ensures the most accurate earthwork quantities. Now, what it used to be is design stage. When you drop your templates out there, you would put a design stage, preliminary or final, and the multiplier would be either a 10 or a 1. We still have the same thing, it's just named feature definition. So we'll go back and change that to what the exercise needs us to do. So we'll open up that 54 corridor. So we'll browse. And we're looking for corridors 54. Enter data 8 folder, and we'll open that up. We're waiting for that check-in box by ProjectWise, which takes a few moments. And here it is. So we'll check in our cross sections ramp 4 file that we were working in. And we'll be back at the Route 54 corridor. Corridors Route 54. Okay, so what we're wanting to do is select the corridor itself and change that feature definition, the old design stage. So we'll select the corridor for 54. We'll get the heads up display. We'll go to the properties, very first icon, and when you come in here you can see that it's already been changed to 1. So we're good to go on that. If it wasn't, if it was at preliminary, you would want to change it to 1. And what that does is if we go to the corridor objects and look at that, what it does is it takes that template drop that we placed out there of 25 foot on our template and multiplies it by 1. So every template drop is 25 foot. And that's what we want. We want to interpolate a lot less. So that's a pretty good distance. Okay, so we've changed that. We've done that step 1. Step 2 says create a new 2D file, and we're going to name that this earthwork _ Route 54. And the job number. So I'm going to copy that, and we'll go over to MicroStation. And we'll go back to the file, and then we're going to go new. We're going to verify we have a 2D file. I see the one that's in here, but I'm going to go ahead and select that seed button and make sure it does go out and grab the one that we need. That design seed 2D. Open that up. Of course, it's read only, and we're going to use it that way. And then I'm going to come here and I'll paste that name of that file that we wanted, earthwork _ route -54 _ J5P 3181. Then I'll hit OK to create that. And this will take a few moments. And we will check in our corridor file. eventually. Again, hopefully this is a lot faster when we push it. There we go. Check it in. And we will be in a blank, brand new mo.seed file. Back to our instructions. It wants us to attach the coordinate system. Now we've done this a few times, so we know we should pretty much be getting the gist of this. So we're going to open our reality modeling workflow. It changes the tabs. Home tab's where we want to be, and we're going to go all the way out to this coordinate system icon. No coordinate system is applied, so we're going to actually pick it from a file that has already had it applied. Done that in the earlier chapter. And I'm just going to pick that corridors 54 because I know it's on there. Open. I'll pick the one that it defaults to. It's the NAD 83 Missouri State Plains Central Zone. It's applied the coordinate system. We're good to go. We'll close that out. Okay. Yeah, and the steps just show how to do that, just in case we've forgotten. Now we're going to change the workflow back to open rows modeling. Okay, so let's do that. A minute. I'm going to minimize my screen a little bit so I can go back and forth between Word a little easier. Okay, it wants us to attach the following files as reference files. Do not, can't stress this enough, do not use live nesting for end area volumes, because you'll get all the files underneath the one that you're attaching, and you don't want that. You want specific files for this. We don't want to calculate for ramp 4, we just want to calculate for our Route 54. So this is why we'll bring in just these 3 files. Civil geometry, the corridors for Route 54, and the terrain. So we'll go back to MicroStation, go to the Home tab, use the reference tool, attach, and we'll do a Tools, Attach, verify you're in Data 8 folder, which we are. We're going to need the corridors 54, we're going to need our civil geometry, and our terrain. We're going to grab those and add them in. We don't need any other files to do this. So once you've got them, you go ahead and hit the OK button. And that's fine. We'll just go through this. And on here, we want to make sure this is 0. And we should get another 2 dialogues after that. So this works just the way it did before. Do a fit view. There's our project. Close down the reference. Back to the manual. We want to make the terrains active, so we can do that. And in the default model, we want to select the F6 button to open 3D. So let's make this active, and then the 2D model that we're in, we're going to hit the F6 2D view, and that way we'll see our 3D as well. Okay. Now, we've done this create name boundaries thing. We're going to do another one, and we're going to do it for our earthwork. Okay, so some of the things will be just a little bit different on this. So to run earthwork end area volume, the user will need to have cross-section name boundaries in place. You'll want to have those. So from the drawing production tab, we're going to select the place name boundary tool, and then the next step is the civil cross-section icon. So let's go on up to our tab and go to drawing production, and then we're going to go to name boundary. The icon's name boundary, so we can just click it. If it wasn't, you'd hit the pull down and choose from there, but it was. And then we're going to make sure that we're using the civil cross-section option on there, which that's this icon right here. Back to the manual. We're going to use a 10 scale sheet on this one. You could use whatever you need. We'll do a 10 scale. And then we're going to do a start location of 603, and then we're going to go to the end of the alignment. So what we need to do first is pick the alignment we're going to go with, and it tells us down here in the bottom left to identify the path. So we'll pick 54, and we're going to come in here, we're going to make this 603 space region 1. We'll lock that in. And then the stop location, I'm going to go ahead and accept that so we can start seeing what's going on here. If you accept that start location, then it's going to start following the alignment, and you can see all the shapes that it's going to place at this point in time because it's set to do 50 interval. But let's go back to the manual and see what we're going to do here. Oh, we're going all the way to the stop location. So what you could do is put your mouse in that field of stop location and hit this button on the right. It'll lock it to the end. Now when you go out, you see it's locked. But before we go click it anymore, we want to go back and look at this. We got end of alignment. Our left offset will be a minus 110, and our right offset is a 170. Okay, so we're going to go 110, and then we're going to make this a 170. We have more room on the right than we do the left, so that we need to use. And we're going to change our interval to 100. When you do that, you go out on your screen, you'll see that it has already changed it to 100 for you. Next thing is we want to check create drawing and show dialog box. So we want both of those on. Then left click in the 2D plan view to accept it. So we're going to do that. Well, we'll left click. And one more time to accept it. Here comes that dialog. Now this part of the dialog, what we want to do is when we're creating, opens up, this dialog opens up. We're going to change the annotation group to the excess annotation without grid, and we're going to uncheck that open model. We don't really want to open the other model. We want to stay in here to do our earthwork stuff. So we'll uncheck that and then select OK. This says on a note, this will create all the sheet models and drawing models, but leave you in the multi-model tool, which is the one with both the 2D and a 3D window. If the open model box was checked, if you left this set on, then you would just want to go back to the multi-model. You want to navigate back to that. Okay, so let's check this out. We want to change our annotation group. Down in the middle of the dialog, pull down, cross sections, drawing, and we want annotation without grid. Once you've got that, and we'll uncheck this. But again, if you forget, all you'd have to do is come down and change it to this multi-model. And we'll run it. So it's going to create cross-section. You can barely see it down there. It's at 4%. 5. These are a lot of cross-sections to cut. A lot of distance we're going through. But it does pretty good. You can see it's creating the sheets over here. It's telling us 32, 35 of 47 sheets. Once the sheets are created, then it goes and creates the drawing models. So you've got those two different models, the sheet models and the drawing models. Right now it's working on the drawing models. And again, you can see that at the very bottom left, at the status bar area. We're at 21 of 47. We are getting there. And there we go. So all our cross-section name boundaries are out there. I can see that I need to turn on the transparency with this over here on that 3D, and I'm going to do that real quick. Just make this active, the window. Go to the View Attributes, and then change transparency. Turn it on. You can kind of see your project a little bit better with that transparency on. Okay, so that step's complete. Let's move over to the manual. Now we're at the Create, Cut, and Fill Volumes. This process will create a mesh surface for each of the cut and fill material for extracting quantities. Okay, so we're going to have to go to the Home tab and then select Civil Analysis pull down. So let's do that. Go to the Home tab, and then we're going to go to Civil Analysis pull down. You've got that pull down. Lots of neat little tools in here. The third step of this step 18 is create cut and fill volumes by selecting the icon. You'll notice that when we do select it, Civil Analysis, create cut and fill volumes, you're going to get a heads-up display. It's going to ask us which feature definition to use, and this is by default already set up. So all we have to do is accept the cut, accept the fill, compute unsuitable, and then compute custom and substrata. We'll talk about in later chapters. We're going to go with no on these. Be more in road 2 that we do it. And then after we do all that, it's going to want us to accept out in a blank area through the defaults. And then one last time, we'll process it. So we'll come back over here, left click one last time. There is a process bar running, and it's created in the background. It's going to give us a cut and fill. And as you can see, shapes show up in both 2D and 3D, the colors. The blue represents cut, the red represents our fill. The process of creating cut and fill volumes will run throughout the existing ground and proposed corridors entirely, meaning that all corridors will be calculated in this process. Therefore, one single corridor per design file is recommended at this time. So even though we got a ramp 4 in here, we didn't bring it in to calculate ramp 4. We just brought in 54, and wherever it's clipped at is where it stops. So, and then again, the meshes are not dynamic. If something changes in the design, then the old meshes need to be replaced with new meshes using the create cut fill volume tool. So you'd have to rerun them if anything changed in here. You change some slopes in your project, you change anything. After you've already done this, then you'd have to rerun this. Next part of it is we need to open up the end area volume report tool. Okay, we're gonna do that. So our meshes are out here. This represents our earthwork. Now we're going to calculate by using the Civil Analysis tool, and we're going to go down to the end area volume report. So still on that Home tab, Civil Analysis pull down, end area volumes report. When you select it, you'll get some options. Right now it doesn't tell me my name boundary group, so I have to hit the pull down to get to 54, because that's what I want to calculate. Just the 54 name boundaries that we created out here. So it's going to look at these boundaries and calculate. Next step is, let me see if I'm doing this. Yep, 54. And then we're going to go ahead, we're going to left click in a blank area. Now, when we do this, it's going to give us some information. It's going to want to know if we want to, let me just go through it. Left click. Now it's going to say select start cross section name boundary for volume exception. So if you had an area, maybe we had a bridge in here somewhere, and you didn't want to calculate that area, you could simply left click on each one of these boundaries that you don't want to keep. You just hover over them and you'd left click, and it would remove them from the calculations. We want them all, so it says reset to complete. So that's all we need to do now is just right click. You would think it'd be another left click, but that's why they got these heads up prompts to read. So we'll reset complete. It processes, brings up our report. Looks just like it did in SS4 pretty much. Got our information out here, got our cut, got our fill, wherever it happens to be. There's not much fill in this project. And again, just like you could before, you could go click on other types of reports and find what you want. But the important part about this is after you run that report, it runs in XML. Let me see if I say it in the manual here. This will bring up a report that has many other volume reports that are created. The importance of this report is that it creates an XML that is attached to each cross-section shape that will allow for annotation. And we have to have that. So I'm going to go back over to this. Did I close that? I sure did. Let me run it one more time. Reset. It's going to process again. Didn't want to close that. Wanted to move it. Didn't want to close it. Okay, here's our report. If I go over into this 2D or 3D model and I select one of these shapes like I do here, and I get the properties on it. Easier said than done. See if it comes up. Properties, and I open up the name boundary, my first one, and I click on it. I'm looking for civil properties, and there it is. This end area volume report creates an XML fragment that looks like this. And that's the way we can place our text in our cross section. So we needed to have that. The other thing about this report tool, which we might have talked about in previous chapters, it just comes out of the box and it always goes to the default side. But when we format, there's some things that we want to change. Format options that we like to see are angular, degree, minutes, and seconds, station that we want to change, the cubic units, we want to change that to convert. All this stuff needs to be done. And when you do it in an SS4, it would just automatically do it. Not in ORD. You have to change this, and then it will, when you close it, it will change the dialog or the report. You can see it change. Station's good now, and our quantity should be a lot better than what it was looking like a minute ago. Okay, so that's the importance of this end area volume, but you got to remember to change that format. I believe we're done with it. Yeah, it's in the box here. Here's our end area volume report. Looks like so. And now what we want to do is we want to add the end area volume annotation to the cross section. So we're going to open up 618 region 2. So let's close this out. And I simply just come into this view tool, and I will navigate to it. And I believe it's 618. What did I say it was? 618. That's what we're going to do. And that's the drawing model. So the sheet models have sheets behind them. The drawing models just say views. Okay. Sometimes this thing opens up and they're in order. So I'm working on a way to get them in a better order. And you'll notice that 618 don't have a sheet, and that's probably because it's in it's in 619 sheet view, more than likely. So we'll go ahead and hit 618. I'll open that up. You can see the annotations out here. It's on this cross section. You can also see where a clipping happened, and it's still labeling, and that again is an issue that we have out with Bentley. Hopefully we get it resolved. Okay, so the next thing we want to do is we want to actually add our annotation for the end area volume. So you can do it a couple different ways here. This is saying it's optional. If you use the major minor grid was used and you want to remove it, you can remove that. We're going to skip down to step number 9. We're going to go to our drawing production tab, and then we're going to annotate the model. That's what we're going to do. So go over to my MicroStation, drawing production, and I'm looking for annotate model, which is under the model annotation pull down. Hit annotate model, and then what we're going to do here is we're going to check yes. We want to annotate everything that we do, so you could do it with this, or the pull down, or the up down arrows. And then the next step is we're going to choose the annotation group of this cross-section EAV annotation. So we'll pick the little three dot button. I'll pull my dialog over. Cross sections, drawing. We want annotation. Now, this annotation group will not work unless you've run that XML report. That's the only way it works. We're going to go back to this. It says next choose the annotation group. Navigate cross-section folder. Use the EAV annotation. Okay. Wow. That screenshot changed on me. It wasn't like that before. So, we'll go ahead and accept this out in a blank area. We're going to accept the annotation group, and it's going to go through each and every one of those cross sections that we've created, which is quite a few of them, and it's going to update it, and it's going to place F4. Get out of that. Oh, it wasn't done. Now it's done. Okay, so it's going to go out and it's going to place this block in all our cross section sheets, and also in the drawing models and in the sheets. Okay. Wow. Somebody got into my document and changed some things. Okay. So what we want to do is compare the numbers that we've got out there, and you can see that they match with the report. And that's what you want to do. And then there should be an end of exercise with that. So this information would match the report that we created, and you could see that it's also in the sheet models. I'll go to 619. 619 has 619 and 20. So I guess 617 is the one I had my sheet for 618. 617, 618, there it is. Okay, and you can see in these that there's no grid on this. If you wanted the grid for your sheet views, you would have to do it in the drawing view. So to do that, you would have to go back to any drawing view, remove annotations, and then apply the ones with the grid. And you'd have to do it for all your sheets. But that concludes this 8.4 section of the manual.